Hi, calculus students. This is what I'm calling a recovery video. And for the rest of the year, I'm going to make these little videos that will usually correspond to a partner problem. And I will make it a recovery video when it's something that I've noticed people are having a lot of trouble with. So something I've noticed people are having trouble with is number one, the difference between indefinite and definite integrals. And number two, working with the notation associated with those things. So what is an indefinite integral? An indefinite integral looks like this, okay? It's an integral sign, and then, fill in the blank with some function, and then dx. So x is normally the variable that we're working with, but this could be dt, this could be dp, it could be d anything. This just means that the variable that we're working with is x. Okay? What is the meaning of an indefinite integral? It means the antiderivative of the input. Okay? So whatever input you have here, this notation means the antiderivative of it. Okay? So use an indefinite integral to represent the antiderivative of this. Okay? So we would use this notation, and then if I want to represent so this means the antiderivative of whatever's inside of it, and then if I put this inside, cubed root of x all over the cubed root of x, this represents the antiderivative of what's inside of it. Okay? Now, for part D, we're going to evaluate the indefinite integral to the left, meaning that we're going to do the operation that it's indicating, which is just taking the antiderivative. So now, to take the antiderivative of this, we can't use power rule the way that it is, but we can rewrite this. Okay, and if this doesn't make sense to you, you should think about it. But I can rewrite this as 5 over the cubed root of x minus the cubed root of x over the cubed root of x. And then I could convert the cubed root of x to x to the 1/3, and then I could bring it up to the numerator by negating it. So what I end up with is 5x to the negative 1/3 minus 1. I forgot the dx. Oh, and by the way, I wanted to say at the beginning, this integral sign and this dx, they come as a pair. Okay, do not separate them. Right? They come as a pair. What we are going to drop them once we've taken the antiderivative, but they come as a pair until we have done that. Okay, so this is the original function rewritten. Evaluate the indefinite integral to the left. So we're going to evaluate this indefinite integral, which means to take the antiderivative of the input. Once we've taken the antiderivative of the input, we're going to drop these symbols. Hi, Laz. My sister just got here. We're going to drop these symbols because if we don't, it will just keep taking the antiderivative, keep taking the antiderivative. Once we take the antiderivative, we're done with those symbols. Okay, so to take the antiderivative, now I could use the power rule. So I'm going to add 1 to the exponent. So I will have, so I'm adding 3 over 3, so I'll have 2 over 3 is going to be my new exponent. And then I divide by it. So it's going to be 5 times dividing by 2 over 3 is the same as multiplying by 3 over 2. X to the 2 over 3. And then this is minus x. Okay, so the antiderivative of 1 is just whatever variable you're working with, so x in this case. And then plus c. Guys, when you find, we just say the antiderivative, we don't say the antiderivative family, but when you're finding the antiderivative, you're actually finding a family of functions, all of whose derivative is the same, which would be this function here. Okay, so this is 15 over 2 x to the 2/3 minus x plus c. Okay? Now, I think it will be helpful if you thought of this as a function. If you thought of this note, when you see this notation, you think of it as the antiderivative function. And the way a function works is you have an input and you have an output. So let's fill in these blanks. So fill in the blank. The input of an indefinite integral is a function. Okay, you put some function inside of here. Okay, so right there we input that function. And now let's think about the output. So fill in this blank. The output of an indefinite integral is the blank of the input. Well, this was the output that we ended up with. And what is it? It is the antiderivative of the input. Okay, guys, so there is recovery video 1, and it is meant to help you on, I believe, the first 3 partner problems of, I think partner problems 5.66 through 5.670, I think. Alrighty, guys, I'll see you soon. Bye-bye.